Okay, cool. So let us print this. So we are having a reference to the second element, and let us get another reference. Let b equals to ampersand of vector of, let's check. So we can print 34, right? But if I try to create a mutable reference, let's see what happens. Hmm, error. Oh, we need to make it mutable. I think this should not work. Okay. So you can see, even if we are referring to different parts in a vector through mutable reference, we can do that. Like for example, hello, yeah.
Yeah, yeah.
For example, you want to change the value of vector at position one and two. You
Yes.
you will want a mutable reference to all these positions, but this does not happen in Rust. We have to get a single mutable reference, then use it, then we drop it. Like you can do like this. So so we can print it. See,
But
so
just a note, in this case, you don't even need the curly braces, because the
yeah,
scope is not defined by the curly braces. The scope is defined by the when the
yeah,
last time the A is used. So if you
yeah,
remove the
that
curly
that
braces,
that, that makes sense. Thanks for pointing it
it
out.
will work.
Thanks. So I think we have made it clear that in any data structure in Rust, you can only have a single mutable reference. Uh, you cannot point to something, two different things with two mutable references. Anyone has any doubt in this?
One more question. Can you go back to that playground?
Yeah.
Um, Playground.
No.
And you had this a string S1 and then S. Can you create it again?
Okay. Let S1 equals to string hello, and
Okay.
let S
And,
equals
and
to,
now and now you have a mutable reference. Can you make it mutable? How come how come this is working without S1 being not mutable?
yeah, because S is not used. I think. Let's see. No, it is not working.
It has to be
It
mutable.
has to
Okay.
be mutable to
Because
have
before
any.
that you didn't have it mutable and it compiled, so I was surprised.
Let's check it. It did not. Oh, in this situation,
Yes.
okay. No, it did not compile.
It didn't. Okay, so we
That,
need to see.
that was covered, I think.
Okay, okay. Okay, I just wanted to clarify that. Thank you.
Okay, so I think we shall move forward.
Yes, yes.
Yeah, we covered this topic. We need a mutable reference to mutate. Mutable references change. Okay, this has been covered. This has been also covered. Covered. Dangling references.
I have a question.
Okay, please.
So when we are printing when we are printing
Okay,
S is a reference to S1, right?
okay.
So I mean, if it's a reference, I thought it would have been a pointer, right? So should it would print out the pointer address instead of the data in S1?
Can you please repeat? Let me. You want me to create something using a pointer address?
And now if we try to print S, it will print out the value of S1, right?
Yeah, I think it should work. Let's see. Let pointer equals to. How do we make it right?
No, 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 remove the line end. Uh, and after let S uh, is equal to at S1,
Okay.
let's print out S.
Yeah, it should work.
My question here is, shouldn't S be a pointer? I mean, S is a reference, right?
Yeah,
So
S is
shouldn't
yes.
it be printing out the pointer's address instead
Uh,
of the
no,
data of S1?
it does not. I think there's something called automatic dereferencing in Rust. So, like for example, automatic dereferencing is a concept in Rust that automatically dereferences. Like for example, let x equals to 5, and you have let b equals to ampersand of x. Let c equals to ampersand of b, and let b equals to ampersand of c. So if I try to print this d, it should automatically dereference and just print 5. So to print a pointer, you can just do, I think it is
Okay.
0p and b. Yeah, this is working. And what we can also do is b, c, b, and x. All okay. Sorry, I did something wrong. Oh, x is not a pointer. Let's see what is. Now see, d is a pointer that is on some address. C is also a pointer, and d is pointing to this c, and c is pointing to this b, and b is pointing to this x.
Okay. So the referencing is essentially just following the pointers to the data they point to
Yeah,
and just printing out that data.
yeah. And to print any data, we can just do star to dereference the value, and it should throw an error. Now it should run. I hope. I hope this makes sense.
Yeah.
Anyone? Any more doubt? So, dangling pointers. So, what is dangling pointer? So it is like something like you have function and function a, and it prints a reference to something. Okay, and let it be equals to hello, and you are trying to return b. Now, in this situation, a problem is that you are return this. This is a reference. This is not a string. Its value is like this. So you are trying to return b, that is a reference to this hello, and as soon as this function ends, the scope of this function ends, this b shall not exist. And if this b is not existing, then what it is pointing to something shall also not exist. So it should be an error. uh, am I clear on this part, or should I repeat?
Uh, Repeat once, please.
Okay, so let me say what happens is b is a reference to this hello string, right? And we are trying to return a reference to this hello, right? As soon as this function ends, B goes out of scope. So whatever I get, like let's C equals to A of, like, now C is a reference to this hello, but as soon as I go out of scope, this hello will not exist in memory. So C is a dangling pointer. Arc, okay, what's the name? Arga. Is it clear now, or shall I repeat it again? Dominic?
For me, it is clear.
Okay. Arga?
Yeah, it's fine.
It's fine. Okay, cool. So in this Rust book, they have written that returns a reference to data owned by current function. Cool. Dangle, and so it is recommended that instead of returning a reference through a function, you just return a value that is owned. Like this S is owner of this string, right? Hello, and we just return this S that is owner. Rules for reference: at any given time, you can either have one mutable reference or any number of mutable references. You cannot have one mutable reference and many immutable references. Either you have mutable reference or any number of immutable references. You can have both at the same time. References must be valid, like we have discussed in this dangly pointer case. References shall be only valid. So let's move to slice. I think this also is a easy part. Has anyone gone through this chapter, slices?
Yeah, it is basically kind of string indexing, making substring of strings using.
It is like a pointer to any part of the string.
Hmm.
Like a star word, this word is a pointer to this part. Instead of just owning this string, we can just get a pointer that points to any part of string. So we can read value, and if you create a mutable reference to it, you can do that. But you can have multiple mutable references. Either S should be mutable or world shall be mutable. So one more case, like this hello. What this B is like, hello exists in memory, and this B is a slice to that hello world. It is like, how do we get a slice? Like, huh? Like for example, this is a let S equals X, B equals to ampersand of X, and so this B in a simpler way is something like this. B is a slice to a string that is owned by someone else. But instead of doing this, we just create a reference. This is a slice. B is a slice. Ampersand of str. Okay, now in the last, I think 2 weeks back we discussed like we cannot have a mutable reference with a immutable reference. Like for example, first word create a borrows a immutable reference to S, and as soon as this immutable reference exists, we are just clearing the string. So it means that word is pointing something that does not exist. So that is bad. Yeah. Is it clear, or shall I explain it more? Arga.
Can you
It looks okay to me.
can you show the code again?
Okay. Can you please repeat, Dominic? I was unable to follow you.
Can you show the code of that function
First,
again? Yes.
this. This one or first?
In the documentation.
Let's see.
Yeah, here. So can you scroll up?
Yeah,
Just a second.
this is.
Yeah, but okay. And can you scroll to that code when it is called? Because
Yeah, let's copy and paste it. We can analyze it here. Now here.
wait a second. I'm just wondering because when we call the first word on the line 4, and how come that reference still exists? Because the first word finished.
Oh,
Because it returned the reference. It returned the same reference, the word, and then the word is used in the print line. That's why.
oh, nice one. I was stuck here.
That's why.
Cool.
That's why
So
we have a still
let's
reference to the S.
check what happens in the S2. Can you do something like this?
You cannot do that because then you move the ownership from S to word, and then S is not valid.
We can. Let's see.
You want to do it like this.
Uh, Wait. What I did was let me first.
Yeah.
What is wrong with this? Is it not saving it? Oh, this is here. Yeah, this is compiling.
This
So
is a this is a different example because you are moving the
yeah, I was confirming if this reference finishes in this block, then can we create the function or not? So it makes sense. If we are returning a reference, then we cannot have mutable because in this snippet what we did was just finish this immutable reference, and the first snippet it was like we have a immutable reference in word, and then we were trying to mutate it, so that was causing an error.
Mhm.
Thanks, Dominic. Next question. So like we have strings, we have other slices like in arrays also. Oh, we have finished chapter 4. Does anyone have any more doubt or shall we move forward? Arka?
No, I think we can
We
move.
can move
I
forward.
mean,
Okay,
we can.
thanks.
Yes.
Using structs are like classes in other languages is a custom data type that lets you package together and name multiple related values that makes up a meaningful group. It is like objects. And difference between struct and tuple is like we have in tuples we don't have a naming convention for the type, and in struct we can name and group a data in a better way. Methods associated functions with the struct are called methods. So this is a basic syntax. Has anyone read this chapter? Or
Yes.
yeah, you have read. So I have a question for you. Struct A equals to, let's see if it is compiling or not. Yeah, compiling. So can you tell me what is the size of this struct A? Anyone?
What is what?
Is
I
the
didn't.
size of this A?
Uh-huh. So the size of the A is the biggest size of the or the biggest type of each of its fields. So the size would be
It
I
will be 4 bytes. It will be 4 bytes. Sorry, and it will be I think 1 byte. Sorry,
or maybe not.
1 bit. Yeah. So size of A shall be Arca.
Yeah, I think as Dominic said, it will be 4 bytes, the highest one.
No.
But maybe yeah, I'm confusing it with the enum. Enum has this what I said. The struct is like sum of all the fields, right?
So you are saying it shall be 4 plus 4 plus 1. 9. Let's see. What is std dot meme dot size of A? I think this is a function to get the size of any value. Okay, sorry. Oh, 12. So can you sorry for that. So how do we find that? We just find the value that is highest in size, like this. I here do or char, and then we just multiplied it by the number of values, 1 2 3. So 12 bytes. I hope that makes sense. If I make it 64, then its size is 16. 8, oh, sorry, its size is 8 bytes. So the size of this A shall be 8 multiplied 324. I hope this is correct. Shit. Sorry. This is also wrong. What we do is we add all these variables, 8 plus 4 plus 1. So it is coming out to be 13. And the maximum size it can allot is the size of struct is a multiple of largest value. Like it can either be 8, 16, or 24 or 32. But it should be a multiple of 8 as 8 is the largest variable in struct A. So as after adding all the values of these characters or variables, our sum is coming 13. So 13 is just less than 16. So the size of struct shall be 16. I hope that makes sense. Arka.
Yeah, okay. I mean, it should be the multiple of the highest value.
Yeah. And it should be like a minimum integer. We can
Mhm.
try it. Like if I make it 128. So 128 size is 16 bytes. So it should be a multiple of 16. So
16.
no. So but when we add this 16 plus 4 plus 1, it is 21. 21 is
Yes.
just less than 32. So the size shall be 32, I think. I hope this is okay. Cool.
Okay, okay.
I think this one is. Other than this, I think
Uh,
okay.
uh, I had a question. Could you go a bit deeper and so that we have a better understanding as to why the Rust compiler does this?
It is something
Uh,
called padding. Uh, to move in memory, Rust do is like we create a block of memory, and it is something like how do I make it rectangle? Let's start this. In this, automatically we create a block in memory, and it should be a multiple of 8. See, I think I read it somewhere. I could find it. But generally, just what it does is like it checks which one is the highest in size, and then we just allot. Wait, so let me put it in phrase. Let's see how just what here. Let's see if we can find it. So it, I can say in simple terms like Rust saves everything on stack memory if it is not if it knows the size of the struct. Like for example, in this struct A, B, and C, all the size of these variables are known to Rust. So A shall be stored on stack first, and then what it does is it calculates the size of this A, that is coming out to be 16 plus 4 plus 1, 21. How do I explain that? Wait, Dominic, next question. Let's see. Padding in struct. Dominic, I will get back to you after this video. I cannot find how memory works,
okay,
but general rule is that we allocate memory like that only. Padding is done to, I think, move faster in memory.
okay.
I'll confirm it. Thanks. Need to put that question. I think this is a easy syntax. We create a object user to. I think I can skip this. We can have empty struct. Okay, so can anyone tell me the size of this always equal? Arka,
Yes, sorry, I missed. What was
can
it?
you tell me the size of this always equal?
I think it should be unit or 1 byte. I think
It is
because there's nothing
it is zero.
zero.
I will confirm that. Zero. And a general rule is that generally what we do is we have variables that are owner of their variables. Like for example, in this struct, every member shall be owner of their value. We generally avoid using references like this. Do I need to cover this rectangle example or is everyone fine with it?
I mean, it is similar to the interface and class thing, right?
Yeah,
I think
I
so.
was asking, shall I cover this example or skip
Uh,
it?
no, I think
I think this is easy,
I,
and if anyone have any problem, I can cover this.
I think it's okay.
Cool. Method syntax. See, this is hi Dominic. Uh, Here it is written that Rust doesn't have an equivalent of a pointer operator. Instead, Rust has a feature called automatic referencing dereferencing. So in that question, somebody asked me how it knows what the value it is. Something like this happens.
Okay,
We can have multiple implementation, or you can just uh, do something like this, or you can have single implementation, put this function in this implementation. Both are same. So I think you must have gone through enum also. Enum B. Can anyone tell me the size of this enum?
no idea. See,
Uh, it
regarding
is
enough.
it is one. Oh, size will increase after we add 256 values. Until that, the size always remains one. We, we can confirm that after, but generally for 256 values, it will always remain one.
Okay,
Okay. Can you come back now? Add to one of the variant any data. Let's say to A you add a string.
Okay.
What is
I think it should be
no
16.
no no no. Let's keep this. Let's keep those.
Ah,
Okay. And now what is the size?
16, 17 out of 1. I think it should be
Now it should be because in enum, if I'm not mistaken, it should be the size of the biggest variant, so that it should be the size of
16. Let's check.
Yes.
24. 24. So size of string is 24. Oh, cool. So if I do
So if you let's say a is yes, and then it should be
24,
still 24.
I did something wrong. Acha, comma.
What is the
24. Correct. So I think this is because enum only cares about one value and it has to choose only one value. So any value shall be less than the size of the highest value in enum. That is what is coming out to be 60, 24. Is that right, Dominic?
yes, in the enum case it takes the highest variant, or the biggest
And because it
variant.
has to only choose one, so it will only care about the highest value.
Hmm.
If you don't mind me asking,
Yeah,
is
sure.
this a Rust unique thing, or do other programming languages also dictate size like this for you know?
Uh, I think in Rust only this is unique. We have something like that. I don't know about other languages. In Java, I did not see anything like this. Others might have some experience with other languages. Alka, do you know any language that has something like this?
Yeah, in actually, I'm from C sharp background, so here actually it's more like the numbering. Quit is zero, move is one, but this kind of complex thing it is mostly denoted with object. It's I mean it's specific to Rust, I believe, this kind of notation.
You can ask ChatGPT if you want.
Yeah, sure.
Can you tell me what is the name? ID8 here. So what enum is? Let's check again. Enums is like, excuse me. Enums allow to define a type by enumerating its possible variants. First, we will define and use an enum to show how an enum can encode meanings along with data. Next, we will explore a particular useful enum called option. Okay, we have enums in Java, but enums are not like this in Java. In Java, I think we have something like this only, either any type, but those does not contain value. So we have a very famous enum in Rust option. Either something exists or something not exist. If something exists, it will return sum of t, else none.
Shivang, just one thing. I mean, this summon none. I mean, is it? It is a fancy way of telling true or false, right?
Yeah, you can say something like that. It's like either it exists or not exist. Like we do not have
I
null in Rust.
hmm.
We generally use enums for that. If it exists, then it exists, or none. It means it does not exist.
Okay, okay.
And we cannot add something like this. If five is x is five, and we have sum of 5. You cannot add these. You have to unwrap this sum. To unwrap, you just do y dot unwrap and then
Mm-hmm.
plus 5. To get the value inside sum, you just do unwrap.
Okay. Okay.
Can I move to next part if everything is fine in here? Or does anyone want me to explain something?
Yeah.
Yeah, we can move.
Okay.
Match control, like coin can be of any type. We can match coin. If coin exists of penny, then we return 1. If it is of type nickel, then we return 5. If dime, we return 10. Or quarter, we return 25. So this is, I think, basic syntax. No, sorry. And one more thing. In maths, what happens is that you need to cover all the cases. Like for example, you cannot just cover one case. Like what I'm trying to do is let s equals to b, and I try to match s, and I just do b a print a, and I think this is wrong. This is wrong because we need to cover all the cases. Oh, what did I do wrong here? Oh, sorry. It should be a. Like we cannot have something like this. It should be exhaustive. Or if you just want to match only for A, so we can do is if let some, I forgot. We can check here. I think it should be B of A. Oh, see, if you just want to match for a specific value, you can just do if let B of A, or if you want to check for multiples, you can just do match S and then just like this. This is a basic syntax and you have to learn it. That's all. Yeah, I covered this thing. I think we have covered chapter number 4, 5, and 6. Does anyone
Uh,
have any doubt?
one more question.
Yeah,
Can you
no.
go back to the playground?
Okay.
So can you also use you can also use then if b a or b b and
If
then print, right?
can you please say I can type if
So if
let
if yes, if let b
Okay, S equals like something like this.
Yeah, what you had before with the if
Okay,
statement.
if let b of b.
Hmm. Or yes, can it be like like this?
Let's see. Found something. I think it should work. Let's check. Yeah, working. If I remove this,
Okay, thank you.
nothing shall print. Ah, nothing. Does anyone have any more question? I was told that we have to
No.
7 to 8 chapter. This is, I think, shall be easy, and
But this is for the next week, no?
yeah, next weekend I think 7 to 8 does not have something else.
Okay.
I will be teaching multi-threading after some time. Okay, so we can drop if you want, or anyone ask any question regarding this.
I actually have one question, not specific to the chapters we've gone through, but kind of generic Rust question.
Yeah, please
There
ask.
are, yeah, when we create any project, basically the command is cargo new, then the project name.
Okay, let's
So
start.
that way we generally start the project or create any new project. Uh,
Okay, let's end it here. Okay, so cargo new. Hello.
yeah. So then the project name. So
Yeah.
now the thing is that there are basically two keywords which I came across. I'm not sure how they get used. It's one is dash dash bin and another one is dash dash lib. So I mean, which one is created for? Which one is used for what and how it
See,
basically works?
library lib is for making a simple library, and in if you do something like this, let me see. Cargo new. This will not contain a main file. So if you uh, now when I go back to now when I do cargo run, main file is converted into binary. So we print this, but there's no binary in this lib.rs. I think arg lib. So we can just do cargo run. No,
Okay.
it is like main is the main starting point, and but library is like we are creating a third party
Mhm.
to use that library in a main file.
Okay. I mean, it's a kind of third party package. Got the point.
Uh, yeah, it is like you are creating a NumPy in Python, and you want to import NumPy in another main
Mhm.
binary. So for that, we create a library like this.
Okay. Yes, yes. Now I got it. Okay.
But generally, for any starting project, we just start do with main RS.
Mhm.
I hope that makes sense.
Yeah, yeah. That's so.
Anyone have any more question, or else I can just stop recording. No one. Dominic, shall we drop?
Maybe I have a question regarding the project related to chapters 4 to 6. Um, shall we expect like additional assignment?
I think for now, I need to confirm that with Radu. I'm
Okay.
not sure on that
Mm-hmm.
because we
Right.
will be creating the project at the end, so it will cover all the basics.
Okay. Mm-hmm. Thank you.
Thanks. Okay, I think we should let me stop the recording and check.